Okay, so what we're going to look at now is we are going to look at the Boltzmann distribution graph for a chemical reaction. What we looked at previously was a bunch of Boltzmann distribution graphs for just particles at different temperatures. Now we're looking at the Boltzmann distribution graph for a chemical reaction. First thing to note, the curve shown means that the temperature, there's only one temperature and you have molecules distributed out at different energies. We're adding an additional detail, as you can see on the x-axis, which says EA uncatalyzed. EA corresponds to the activation energy of a chemical reaction. So you have reactants, which is what is shown on the graph, and only reactants that are moving with enough energy or more energy than the activation energy can collide together to form an effective collision, a reaction. And we're saying uncatalyzed because at present there is no catalyst present. So our reaction container with no catalyst, you have A and B colliding together. If we look at what happens when A and B collide together inside at a low energy state, what you can see is that the electron clouds repel each other far too much for those two reacting groups, the Pac-Man and the triangle, to get close enough together. So we can see our little collision effect. It's not a very large one. So the electron cloud repulsions, the strength of the electron cloud repulsions is more than the energy of the collision itself. When the energy of the collision itself exceeds the strength of the electron repulsions, you can have a reaction occurring, which is what we see occurring on the right hand side here. So because A and B are traveling faster, this is why I've put them on the right hand side of the graph, where at high energy, they're colliding fast enough for the electron clouds to effectively be pushed out of the way, and for those reacting groups to be brought close enough together in space to actually form a chemical bond. So this is what is happening when a chemical reaction happens in a container. Only if the particles collide with enough kinetic energy can they overcome the repulsions of the electron clouds. As such, a chemical bond can be formed. It is very important to note that it also has to occur with the perfectly correct orientation. If it doesn't occur with the correct orientation, the collision, there will not be a chemical reaction. This is the uncatalyzed example of A reacting with B.